everybody, welcome to Unit 12. Unit 12 only consists of 2 small sections of notes, and we are going to be dealing with circles. Now, there is a ton of stuff we could cover with circles. However, due to the time constraints, I'm going to focus on things that I believe that if you are going to take any sort of special test after geometry, like an SAT or an ACT or an ASVAB, this is the type of stuff that you may be asked, so I just want to make sure that you have some exposure so that you're ready, okay? So let's get started. So the first section notes we're going to focus on is circumference and arc length. And what I have on our first slide here is really just words that I feel you should be familiar with, but just in case, we're just going to go over them. So first things first, whenever we talk about circles, a circle is always named by its center. So if you look at this circle over here, that point in the middle, which I've named H, would tell us that we could call this circle H. Now, like other things in geometry, you can replace the word circle with a symbol, and that would really just be an actual circle with a dot in the middle to indicate its center, and then the letter H. So that's how you would name the circle. First word here, guys, is the circumference. The circumference is the distance around the circle. So just so we're clear, okay? So whenever we're talking about the circumference, we're talking about all the way around. So it's sort of like saying the perimeter of the circle, but they have a special word for it, circumference. The diameter. So sometimes people get confused, the diameter versus the radius. So the first one we have is the diameter. The diameter goes straight across the circle through the center. So basically, if you start at one side and just draw a straight line, a segment, and cross to the other side of the circle, making sure that you pass through the center, that is the diameter, okay? So all the way from here to here, we call the diameter. I'll put D for diameter. But then when we talk about a radius, the radius instead is really just a part that goes from the center out. So a radius is actually just part of the diameter. He's just starting at the center and then going out to the side. So you've got the radius as the small one and the diameter as the big one, okay? And then because of what you see up there, you might already know this as well, is basically if the radius is from the center out, well, if this amount is the radius, well then over here is also the amount of the radius, and that gives us our first comparison between the diameter and the radius, and it's that the diameter is twice the radius. So if you have the radius and you just multiply it by 2, you'll always be able to find the diameter. And then just the reverse of that, if let's say you have the diameter and you want to figure out the radius, well, the radius is half of the diameter. So you take the diameter divided by 2, and that will always give you the radius. And then another formula here, guys, is the formula for circumference. So the formula for circumference is C for circumference equals 2 pi r, and of course that r is the radius. And this is actually the formula that you will see on formula sheets if you do take the SAT, the ACT, the ASVAB, etc. So you should know this formula, but if you forget it, it will always be given to you. All right, so let's work with just those first concepts there. So right here, I've just given you a few circles, and I just want you to answer some questions about it. So first, we've got our circle right here, and we want to know what the name of the circle is. Well, we just said that we named the circle by the center, so we would call this circle G, or of course you could be fancy and do the circle with the dot and then the letter G. All right, what is the length of its diameter? Well, the only reason I'm asking you that is because I've just given you the radius. So I'd like to make sure that you know that if you're given the radius and somebody would actually need the diameter, that you know how to do that. So if you remember from what we just talked about on the other slide, the diameter is always 2 times the radius. So basically, if I just do 2 times 3, which is what I'm given there, that'll give me 6, and that will be my diameter. And that could be inches, feet, yards, whatever. Right now, I didn't want to mess with units, so you can just give the number. And then last question to review what we've got on the front, what would be the circumference of this circle? So remember that our circumference formula is 2 pi r. And just to clarify what this italicized statement means, it says to express your answer in terms of pi and then as a decimal. So a lot of times when you take standardized tests and they talk about the circumference or the area, they're going to actually express their answer with the pi left in there. So this is why I'm going to actually expect that you understand the concept with leaving pi in and what it would actually mean as a regular number like a decimal. So let's just start by plugging in what we have. We know that the radius is 3, so we're going to go ahead and plug in that 3 in there. So that's going to give us 2 times pi times 3. So when we express something in terms of pi, basically, guys, I want you to treat it like it's a variable, and it just kind of keeps just getting thrown to the end of the problem, and all the numbers do math around it. So we're going to go ahead and multiply the 2 and the 3 to give us 6, and then we're just going to put the pi right after it. So the circumference for this circle is 6 pi. So again, like I said, if this were like an SAT question and it's multiple choice, you would see all your answers with pi's in them. But now let's say you were actually using it for real. You had to calculate some probability or something, and you actually had to know at least a rounded number for it. So for the second part, guys, I just want you to also know the decimal. So what we're going to do, guys, is in place of that pi, for our purposes, guys, we're always just going to use 3.14, okay? So if I go ahead and do 6 and then multiply it by 3.14, and I've got my calculator for that, 6 times 3.14, that's going to give me 18.84. So our circumference is 6 pi, or as a decimal, it's 18.84. And we'll just do one more problem, except now notice that I've given you the diameter. So first question, what is the name of the circle? Again, the circle is always named for the center. So we're just going to go ahead and say circle P, or a little circle symbol and then a P, okay? What is the length of the radius? So notice that I'm asking for the radius because it's just the one dimension they haven't given me. Instead, this time I'm given the entire diameter. So therefore, I need to remember that the radius is really just the diameter divided by 2. So I'm going to take that diameter that was given to me, divide by 2, and that will give me 10. Now, in particular, knowing that the follow-up question was to find the circumference, yeah, we would have had to have done this question regardless. Because again, the circumference formula is 2 pi r. And we're going to take that radius we just found, which was 10. So notice, guys, there's a 10 going from this center out and a 10 going from this center out. That's what makes the diameter of 20. So we're going to go ahead and we're going to plug that 10 in for the r, and then we'll have the 2 times the pi times the 10. We'll multiply the 2 and the 10 to get 20, and then we'll just go ahead and leave that pi alongside. So the circumference of this circle is 20 pi. Again, if we're interested in the decimal, which I am, I'm going to go ahead and I'm going to take my calculator. I'm going to take 20 and I'm going to multiply it to 3.14, and that will give me 62.8. So what you'll find on the homework or the quiz is that sometimes I'll leave it in pi, sometimes I'll have the decimal. So I just want to make sure that you're comfortable going from one to the other. All right, the last part of these notes is now we're going to look at not the entire circumference, but let's say I just want to look at one portion of it, okay? So if you think about the circumference as sort of like the crust around a pizza, now what I want us to focus on is, well, how much crust would there be on just one slice of a pizza? And this is what we call an arc. So just a few key ideas and concepts before we do those two problems is, first, we want to know what a central angle is. So down here, a central angle. So a central angle in a circle will have the center as its vertex, remember the corner, and radii as its side. So now just so we're clear, because I realize that's the first time we've used this is just radius, but the plural form. Okay, so radius plural is radii. So basically an angle has two sides, so therefore I need two radii drawn. So from the center, let's say I go center out. That's one radius. Center out, that's a second radius. So those would be my sides of the angle, which are both radiuses, radii. And then the central angle itself is then just that little area right inside there. An arc then is basically the connected section of the circumference, okay? And it's formed right there by these two radii. So the arc in this case, based on the ones we drew, would be this part right here. So just to be clear, this would be the arc. It's just part of the circumference. And for our purposes, we're going to only focus on arcs that are formed with that central angle and two radii, okay? And again, this is called a central angle because its vertex is the center. So the central angle is that little bit that's formed there. And again, connecting those two sides there, that's what we call an arc. So the second part, the last part of these little notes, guys, is going to be to actually find the length of that arc. And this is the formula you're going to use, okay? Now again, there's a couple different ways you could do this. I prefer to create kind of like a proportion so that you can kind of see the comparison. What's going to happen is this right here, guys, will represent your central angle. It's technically a theta, which is a Greek letter just representing an angle. I decided to use that instead of a letter because I didn't want you to get confused with this X here. This X will represent the length of the arc, okay? So just so we're clear in our formula, we're going to be solving for that X, giving us the length of just one little part of the circumference, and this will be the central angle. So if you notice what's happening in this formula, right now, guys, if you haven't written down anything up until this point, make sure you write this down. So what's happening here, guys, is however much is in that angle out of the entire 360 degrees in a circle is going to equal whatever that tiny little part is of the entire circumference. And that's what the 2 pi r is. Remember, that is just the circumference. So it's this little formula, this little proportion that we're going to plug into so that we can now just find part of the circumference instead of the whole thing. So our last 2 problems right here, and what I'm actually going to do is I'm just going to write this formula again at the top of my new slide. So I've got theta over 360 and then x over 2 pi r. And that's what I'm going to need for these 2 problems here. So notice the change in the directions. It says find the length of the indicated arc. So you'll notice that the arc will be highlighted, and you'll also have that central angle given right there by the center. So plugging into our formula, the theta is the angle in the problem, so that'll be 120 over 360. Our x goes on top, And then that bottom is just the circumference, which requires the R, which is given to us in the problem, which is 3. So 2 pi, and then in place of the R is the 3. So the first thing I'm going to do is basically, I'm just plugging into that formula. Now at this point, I like to just take a second and just clean it up a bit. So for example, on this right side, I'm going to now make that 6 pi. Again, I'm not taking the pi out just yet because it does say to express your answer in terms of pi and then as a decimal. So I'm just going to leave the pi there. It's going to make it a whole lot easier. At this point, if you want to simplify the 120 over 360, please feel free to do so. I'm just going to leave it. Again, you could technically have crossed out the zeros. You could divide it, each by a 20, a 60, whatever. Doesn't make a difference if you simplify this first or not. You're still going to get the right answer as long as you know how to solve a proportion. So solve the proportion. We're just going to cross multiply. We've done a lot of that. So it's going to be 360 times x. That will give us the 360x. And then we'll also have this part right here, 120 times 6 pi. Remember how we did the multiplication up here for the circumference? All we're going to do is 120 times 6, which I believe is 720, but now I'm doubting myself. So 120 times 6, yep, 720. And we're just going to throw the pi right next to it. Okay, don't even worry about it. Remember, like I said, it just keeps carrying down. Now we'll go ahead and divide by 360 on both sides. So we get x alone, and we'll get our final answer. So our final answer here, guys, are x, 720 divided by 360. Yep, just what I thought, 2. And then we'll pull that pi down. So basically what's happening here, guys, is whereas the entire circumference of this circle is 6 pi, right here, just that one section there is 2 pi. This is also why I want you to keep the pi, so you can check the reasonableness of your answer. If this would have come out to, let's say, 20 pi, hopefully you'd stop and say, well, that's not going to make sense. The whole thing is only 6, okay? So, and some of you might notice it's like a third of the 6 pi. Well, that's also what 120 is out of 360. It's a third, okay? So that's how that kind of formula relationship works. So let's just do one more, and then this video is done. All right, so with our last problem over here, now notice our central angle, tinier, but no matter. 45 over the 360. And that's going to equal to x over 2 times pi times the r, which is 14. Again, I'm just going to clean that up a bit. I'm just going to keep the 45 over 360. I'm not going to stress myself out. I got a calculator. Over here, 2 times 14 is 28 pi. And now we're ready to cross multiply. Definitely going to get some bigger numbers, so let me make sure I've got my calculator here. So first things first is the 360x, which again, guys, notice is the exact same thing that's over here. So that's always going to be that left side once you go ahead and fill in the pieces and cross multiply. Your right side, of course, is going to change because that's the one that's based on the central angle and the radius. All right, 45 times 28, guys, is giving us 1,260 pi. And then we're going to go ahead and divide by the 360, and I get 3.5 pi, no matter. Okay, sometimes the coefficient of pi is a decimal, and that's okay. So we get 3.5 pi. If you wanted to, you could always make that into a fraction. 3.5 is 7 over 2. Okay, but I'm fine with the 3.5. And then lastly, I just noticed, guys, actually, let's double check that real quick. So the entire thing is 28 pi. This ends up being just 3.5. And if you think about it, that makes sense because it's definitely less than half the circle. So it would definitely be less than the 28, less than the 14. In fact, if you notice, it's almost like it is even less than a fourth of a circle. So yeah, it makes sense that it's only 3.5 pi when you compare that slice with everything around. And then lastly, it did say, I'm sorry, I forgot this, to round to 2 decimal places then. So just real quick, 2 times 3.14. For this one, that would be 6.28. 3.5 times 3.14 is 10.99. All right, so those are our problems for our arc length. All right, so guys, if you have any questions, please make sure you ask. Please try the homework so that we can get some extra feedback. All right, and good luck. I'll see you in the next video, which will be the last one. Yay.